Okay, so the first two should be fairly simple with just parts of circles and naming circles. I'm not going to do any specific one there, but I'll just take a quick look here. You're just trying to figure out, is it a chord? Is it an inscribed angle? What are they asking about? Please identify the highlighted part here. So, like for me on this one, it would be a central angle. That's what's highlighted on my diagram. So there's just a few of those just to look at. That's just parts of the circles. Naming arcs also should be fairly easy. We've done those in our notes. This one is a highlighted arc. So it's a major arc. So you'd want to name it with 3 letters. You'd want to start with Y. You got to start with Y, or you could start with E, either way. But if I start with Y, I need to go this direction, and I could use any of these other letters. I could use H, T, or Q in between E. So I started with Y here. If I start with the Y, and I should probably put capital letters, I have to end with E, but I'm going to need to either use H, T, or Q somewhere in there. So if I could put the T if I want to, and then I have to end with E. That's what I need to do to name it. So I just couldn't say YE. That's the only thing I couldn't do really, because it is that's not the highlighted one that was highlighted for us. That would be the minor arc. So that should be fairly easy to do as well, the naming arcs. But then let's come into these inscribed angles. So I got 2 of those we'll do. So these 2, let's look at these 2. Central or inscribed angles level 1. Got a couple of these here. So for this one, it's telling us that QTS, that's this inscribed angle here, is 37 degrees, and it wants you to find the measure of the minor arc QS. So that's fairly simple. It's just going to be twice the amount of that inscribed angle, so 37 times 2. You could probably either do that just in your head. That's going to be, what, 74? So 74 degrees on that one. So it's an inscribed angle. It's just going to be twice for the arc, times it by 2 to get the intercepted arc. So that one was fairly simple. You have another one here on same thing, central or inscribed angles level 1. Level 1 is going to be a little bit easier than the level 2, so just realize that. Here it looks like a central angle we're given. We're shown a central angle. It says that the measure of the arc MP here, this arc, is 114 degrees. Find the measure of MNP, which is that central angle. So the arc and the central angle are always the same. So that is the same as 114 there. Central angle is always the same as the intercepted arc. So this would be just 114. Okay, so that should be fairly simple on this level 1. Intercepted or inscribed angles are always half of the arc, but if it's a central angle, it's the same as the arc. So you have 5 of those to do, which is fairly simple. Go down to level 2, central angle level 2, first one of that we'll do together here. Uses kind of the hourglass kind of situation going on there. Just more stuff inside here. So it's got in circle P with this angle, NPQ, that's equal to 90. So already tells us that NPQ, which is a central angle, is 90. Find the measure of the angle NRQ. So NR and then Q here. So NRQ has the same arc of Q to N that this 90 degree angle has. So if this is 90 for the central angle, then Q to N is 90 as well. And if this right here is an inscribed angle, right there from QR to N, or NRQ, then that angle there is half of what that arc is. Which, if that arc we know is now 90, half of 90 would be 45 for that angle. So the answer here is 45 degrees. It didn't put the degree symbol. I think that should be okay, though. Should be just 45. So you don't need the degree symbol. I don't think there's any way for us to type the degree symbol anyways. But that's just what you want to recognize, is that angle right there is what we're looking for, that they kind of highlighted in green there. And you knew that because it was half of this arc, and we found the arc because the central angle is 90 for that arc, so that means that the arc is 90 as well, and half of 90 was the 45. So just a little more on that. Okay, one more of those. It's the level 2. Here's another one. So it's got the inscribed angle here over at G and the central angle there at the center point E. It says in this circle E, the measure of DGF. So DGF is the inscribed angle here, is 42, it tells us. What is the measure of the central angle then here? So if this is 42, then the arc that it creates, the intercepted arc, is twice that amount. So if you multiply 42 times 2, that's 84, and then that would be the same as the central angle here that they're asking about. So central angle is 84. If this arc is 84, based on this inscribed angle being 42, because you're going to double it to get the arc, then the central angle is also 84. So twice 42, just need to see that. So there they highlighted the green one. That was the green one they were showing us. We needed to find out what this central angle was. And you have 5 of those to do. Okay, so there'll be 5 of those ones. Then it comes into the algebraic, central and inscribed with algebra, which means we're going to be setting up equations. So the first one here, so it shows us a central angle. So it says in circle M, KML, which is this central angle here, is 73 degrees. So we know the arc is also 73 degrees as well. Okay, if central angle is 73, then KL's arc is 73. It's a solve for x. The measure of KL is this expression, so that expression equals 73. So you'd set up an equation. So our equation would be 4x minus 32 which is that expression, and it's equal to this measure of the arc here, which we know now this arc there is 73. So there's our equation to set up for x. Just add the 32, and so that gives us what, 105. 5 there, and so yeah, 105. This is not going to come out. So yeah, necessary, round your answer to nearest tenth, which we will get a decimal. So we're going to have to divide this by 4. So I'll just go to that calculator that's up here. 105 divided by 4. And it's 26.2, and it says nearest tenth, so one decimal place would be 26.3. That's what I'll put down here, 26.3. Set up the equation, add the 32, divide by 4, and you can get a decimal. So we'll round it to the 1 decimal place. So since this was a 5, we had to round the 2 up to the 3. Okay, next one that we'll look at, another one just like that, another one similar to it. So a different diagram. It's telling us that here's an inscribed angle. So this time they put an inscribed angle there. And they said the arc that it creates here, the TV arc, is 94, but the measure of this inscribed angle, TWV, is this expression. So when we're setting up our equation this time, set the equation up this time as 5x minus 45. Okay, that's our inscribed angle there. So that's this angle here. And we know that this angle is half of what 94 is, because if this is 94, the inscribed angle is half of that. Half of 94, that would be 47. So it's equal to 47. And then we can just add the 45. So that's going to give us a 12, carry 1, 92. And we're going to get 5x equals to 92 divided by 5. Again, we're going to have to round this. That's not going to go in evenly. So again, using your calculator, just to do 92 divided by 5. 92 divided by 5. Oops, got to clear it. Always do that. 92 divided by 5. So that's 18.4. So we don't even have to round it. It just gave us one decimal place. 18.4. So a little scratch work with just setting up equations. Just be prepared to do some side work to set up your equations here. You can put your scratch work right in your notes if you want to. Just find some space in your notes, and that's where you could do scratch work. Keep it right in there. Alright, so those two. Then you'll have 5 of those as well to do. I should probably go back and put 3 there because I have a longer assignment. I might change those to 3 after I'm done. Probably will. Okay, so coming right down here to right angles. So it gets a little more challenging on some of these because the diagrams can get a little more involved. So right triangles, we'll look at one of these in circles. So I have this, everybody should see this diagram. And it's got check boxes here. So check boxes means you're going to have more than one answer. Check all the ones that would be true with this. It says select all that apply. So it tells us we have a circle C. We have a diameter of BV here going across, center. We have a tangent. We have 2 tangents, in fact, VM and PX. So here's the PX is going this way. VM is going this way. It says which of the angles must be right angles. So we need to remember the theorem that says a tangent line and a radius, that creates right angles. We also need to recognize and remember that we have a diameter here, cuts the circle into 2 equal halves, and so we have a 180 degrees for a semicircle, which can be an arc. So we need to look for any of the ones that have a tangent and a radius. So let's look for tangent and radius first. So right here, here's my point of tangency at V. This is the point of tangency. I have CV for a radius. That angle right there has to be a right angle. Okay, this is perpendicular here. So that's a right angle. Like CVK is a right angle, or CVM. That's a right angle. So do we have those down here? CVM, there's one. So CVM, we don't have, do we have a CVK or a KVC? Anything that starts with K? No, nothing that starts, anything else that starts with C. CPM, no, that's the other one over here. So that's the only one from this side, okay? P is also another point of tangency. So CP is the radius there. So yes, both of these here on this side of P, point of tangency and radius, those are right angles. So like I said, CPX or CPM, that would all work. And that's the CPM right there. CPM is definitely a right angle. You could say XPC, but that's not up here. That's not there. Now, there is one more up there because we have this inscribed angle right here, BP to V. This right here has to be a right angle because the arc it creates is 180 degrees. So half of 180 is 90. This angle on this kind of triangle here has to be a right angle. So BPV or VPB, I think it's the B one. Yep, BPV, that one right there. That has to be a right angle as well. BPV on that one. And you could just go through the rest of these and just double check P, M, and V. So P, M, V. Now there's no way for us to know that that's a right angle. PCB. So PCB, nope, there's no way to know that that's a right angle either. And then this last one, BPX. So BPX, definitely not a right angle. We could tell that's acute for sure. So yeah, just those three have to be right angles in this diagram, based off of the tangent, point of tangency and radius, and the inscribed angle with a semicircle. So if your inscribed angle creates a semicircle, that inscribed angle has got to be 90. And then you can see I highlighted all the ones we looked at there, the three, put the right angle boxes on those. So you'll have three of those where you got to figure out the three, or there could be only two, just all that apply. So it's not always just going to be three of them. It might be two of them, or it might be four of them. I don't know. Okay, so there's three of those. We'll come down to the next one where it says Pythagorean theorem in circles. Let's take a look at this one. So another big diagram, a lot of lines going along, so don't be too overwhelmed by it. Just try to start reading through it and see what it's asking you to do. So in this circle E is the center point there. You have a diameter of CD. Okay, so there's that diameter right there. You got a radius of EA, so E to A is also a radius. AB is tangent to E. Okay, so if that's tangent to E, we know that that creates a right angle in there. Okay, it does create a right angle. So AB is tangent to E and A. All right, so tangent AB is tangent to E at A. Okay, so yeah, that line right there, E at A. If AD is 12, so if AD is 12, then we know this here is 12, and CD is 30, so CD, C to D is 30, that's your diameter. Can we find AC? It says round your answer to the nearest tenth if necessary, and it says if answer cannot be determined, click cannot be determined. So you do have an option here where it may not be able to be determined. If you can't figure out that you have a right triangle, then you can't figure out a side length. So what you want to try to notice is which two sides did they give us of a triangle? They gave us AD, that's this short side here, and CD, that's this longer side here. So we would have we have to do AC as the completion of that triangle. That's what they're asking for. That's the triangle they're asking about there. So identify the triangle you're looking at. They gave you two sides and they're asking for a third side of a triangle. So now you just need to figure out, okay, is this really right here, is this a right angle? And because DA and C, that angle creates an arc that is a semicircle of 180, that is a 90-degree angle. So that is a right triangle. So you just need to verify that that is a right triangle. If there was no way to verify the triangle you're working with is a right triangle, then you might be needing to click the cannot be determined. Okay, that might be true. But once you verify, okay, that is a right triangle, so now I can do the Pythagorean theorem, where I do a squared plus b squared equals c squared. So the c is the hypotenuse, that's the 30. So let's work on that now. So we'll look at, so a squared, so we're going to do basically AD, I'll do like this, AD squared plus the AC is the other leg, AC squared. It's equal to the hypotenuse of CD squared. Okay, so now just fill everything in. So our AD, they tell us that's 12. So it's 12 squared plus, I don't know this one, so maybe I'll just put x for that one, x squared, just a variable. And it's equal to CD, which they say CD, or yeah, CD is 30, so 30 squared. So that's what we're doing, 144 here, plus x squared, and it's equal to 30 times 30, that's 900. So I subtract my 144, cancel those ones, minus a 144 over here. So x squared then will equal, let's borrow, let's make so that's going to be, so it's going to be an 8, 9, and a 10 then. So it's going to be 6, 5, and 7. 756. So we take the square root of 756. Let's go to our calculator and do that. Calculator. So 756 square root. So let's see if I hit the clear this. I hit with the square root and then 756. There it is. 27.45. It says nearest tenth. 27.5. So 27.5. X, or our answer for AC, we'll just put AC down here, is 27.5. It should make sense because it should be less than the hypotenuse, which it is. 30 is the hypotenuse. It should be more than the 12. That's the short side. So 27.5 we'll put down in here. And there you go. So again, you got to understand what triangle are they having you look at inside of here. Is that a right triangle? And if it is, then you can use the Pythagorean theorem to solve it. But if it's not a right triangle and you cannot determine that it's a right triangle, then there's not a way to determine what that side length is that they're asking about. So you might use that one button down there which says cannot be determined. That's possible. Let me see if I look at this one. Let's take a look at another one just to see what we'll be talking about here on this particular one. You don't have this same one, but you can, maybe I'll just pull it off like that so I can draw on it for a second. Make it bigger. Will it become bigger? Yeah, make this a little bit bigger. Let's see what they say. So they're saying AD is 18. So AD right here. They're giving us that side, and EC is 15. EC is here. It's 15. They want us to find AC. They want us to find A to C, which is A to C over here. So AD 18, EC is 15. And then they want us to find that one. Okay, is there a way to do it? Well, let's see. If they tell us EC is 15 right here. That's a radius, E to C. And E to A is also a radius. Okay? So yeah, you could say that's 15, and this is 15 also. So you could figure out AC as long as that's a right triangle. So now you need to notice, okay, well, is it a right triangle? What does it tell us up here? We have a diameter, radius EA, AB's tangent at E. So it means that this is a right angle here, so that would be a right triangle. This one's a right angle going that direction. So we're trying to figure out really is that this would have to be our right angle in here. So going across here, this is a right angle to this tangent. So I don't think there's any way to figure out that that's a right triangle in there, like a right angle. That's what we're looking at. Is that a right angle in there? To see, could we do a Pythagorean theorem with that. It doesn't look like there's any way to show that that's a right angle. So that one I would say probably cannot be determined on this one. It doesn't look like that's going to work. So it should be fairly obvious that you're going to be able to do it. And this one, we know this is a right angle up here. Yes, that's a right angle here on this one because of the point of tangency to a radius. But as far as the angle going down here, doesn't, no. So I probably would be picking that one. And no, there is a way to do it. So, yeah, so there's a way. So I'm not seeing AC. Oh, here it is. Okay. Yep, now I see it. Once I backed out, I could see it better. Let me erase this so I could show you what I'm looking at. So again, let's highlight first what I'm trying to find. Trying to find AC. So that's this side right here, which can be a part of this triangle here, which is two radiuses. So we said, okay, they told us AD is 18. That's 18 right here. So that's this side of a triangle. And they tell us that EC is, what is it, 15. So if that's 15 here, ED is the other. That's also 15. So that whole thing's 30. And so that would make this needing to be a right angle, and yes it is, because this angle ADC is creating semicircle, so yes, that is a right triangle. So yes, we can figure out what this side is. Pythagorean theorem with same thing. So yeah, sometimes it is challenging because there's a lot going on sometimes in these, but just if you try they cannot be determined and then you know for sure that it can be, then you just got to figure out, okay, there's got to be a way to see a right triangle so I could find that side given the information that they gave me. Alright, let's go back. So we did that last one. One more here with circle properties. This will be our last one I'll look at together. So another big diagram inside here. It says you got a circle R. We have a diameter going across here. We have a tangent line as well going outside here. It's tangent to R. Tangent to this radius that's right here. It says name an angle that's congruent to SUT. So you got to understand, okay, where's SUT? S-U-T. So what angle that is a right triangle. So there's another right triangle situation, kind of like that diagram we just looked at, because it creates an arc of 180 degrees. So it's an inscribed angle that's half of 180, so that's definitely 90. So what else could be a right angle? And we got to type it in. So another right angle could be using the tangent. So RUV, that's a right angle. RUW, that's also a right angle. Either one of those I think will work down here. Those are the two that are right angles because the tangent and radius there are going to be right angles. So I'll just put R, U, use capital letters, R, U, and W, put that one in. And yep, so it's showing you could go either way on that. It says there's, I think, a couple different options that you could have got. Yep, either one of those, two possible answers. It shows you, again, the whole idea there with the inscribed angle there being 90 because of the arc that it creates is the diameter, which is 180. Also right here it shows you tangent to a radius is also going to be 90 as well. Those are the two properties we're looking at and going off of. Alright, so now you're going to go back and just all the ones that you have to do on your own, go through those. I'm going to probably fix these. I think I'll just change those to 3 on those ones. So you can start working on the top ones or some of these other ones while I'm fixing that. So you have the rest of the time, which is like 10 more minutes here, and then whatever you don't finish, just keep working on your own.